The following program is a special presentation of the Big Ten Network, produced in association with the University of Illinois.
It is a competition unlike any other. Teams work around the clock, turning the National Mall in Washington, D.C. into a virtual city. 20 universities from around the world are selected to build the house of the future. After almost 2 years of designing, building, and wiring, one team will be the winner of the U.S. Department of Energy's Solar Decathlon.
Just got the foundations all set up. We're going to wait for Homeway to bring the house over.
Look at the technologies that are being developed and how do you actually get them to work and integrate together.
This house is a good illustration of how some thoughtful preparation can lead to a good living space that's kind to our environment.
It's a group of university students from Illinois. We're basically taking apart a barn. Preparing for this project since January of 2008. We're doing it for the Solar Decathlon. There's a team of architecture students, there's engineering students here, both electrical, mechanical. We've got an urban planning student, just a large variety of people working on this project. Heads up, heads up. I grew up just down the road, lived there my entire life. My grandparents have lived here as long as I can remember. The barn itself hasn't been used for, many years. My grandparents sold the land, and with that, we kind of jumped on the opportunity to take this barn and use it in the Solar Decathlon. So in the competition, there are points awarded for sustainable elements.
We're getting familiar with what's basically been the inspiration for our project, which is vernacular architecture, what is traditionally built in Illinois. And it's been a great opportunity for the students to come and see a barn. It's important to actually understand what goes into a building, and by taking a building apart you actually get an understanding of that, and you really get an understanding of how construction comes together, how you can use very simple techniques to make a very beautiful environment.
Illinois, go on high!
This is how the boards came off the barn, and the first part of the process is just scraping off the real loose stuff. Then they come over here for 2 coats of paint. The girls are just getting into that, and Daniel's helping out.
The team prepares a site on campus for the delivery of the home from Homeway in Peoria. Since the home will be moved again to the National Mall in Washington, D.C., they had to create a unique foundation design to minimize its impact on the ground. The home sits on 20 concrete footings that are reinforced with steel bars. The load will be transferred to the ground, maintaining less than 1,500 pounds per square foot pressure. Professional home builders Homeway Homes in Peoria, Illinois, partnered with the Illinois Solar Decathlon team.
As a University of Illinois project, I think it's really important that students kind of work with industry that is local to them. And this is a perfect opportunity to do that, where their drawings actually become reality.
They wanted us to try to incorporate our manufacturing process into a project that could be a passive solar home.
Decided that we're going to go for it. We're going to do our design work and help the university decide this project. We can actually take their dream, their design, and put that into actual building of this home.
We have an R80 in the sidewalls. We have nearly a R160 in the attic. So when we get all done with this project, it's going to be a total envelope of insulation. Inside also is a product called bamboo.
This is bamboo. Bamboo grows so fast, it renews itself every 3 years and produces 14 tons of usable fiber every 3 years. Compared to southern yellow pine, which is around 8 tons per acre every 25 years. Really excited to be able to use this in this project. We've achieved 5 times the safety factor for structural properties, so we know it's going to stand and last the test of time.
The home it's 52 feet long and we're about 13 foot 10 wide. It's a 1-bedroom, but it's a self-sustained home. We have a kitchen, a living, great room out here, and there's laundry facilities in here. We have a dual shower head in the bathroom. Basically everything in the home has been designed custom.
These are our high-performance windows which we've imported from Germany from a company called OptiWin. They've got triple glazing in them, but the most important feature of these windows is the 3 woods that they use in the construction. The most important one being the cork on the outside, which really helps as a good thermal bridge. It's been a great learning experience for these students because they've realised that what they design and what they specify really does have a commercial implication, whether it makes the project more affordable or less affordable. And you can do that with textbooks, but there's nothing the same as actually doing it in reality. And this experience has really been good for our students to see that. It's pretty nice, huh?
We are here today at Champaign at the University of Illinois to set the Solar Decathlon house that we've built in our factory over the last couple months for these students and set it on the grounds here so they can finish it up, ready to go to Washington, D.C.
Oh, it's great. Finally seeing it here is excellent. It's got a perfect site. I know, although it's a temporary site. We can run all our PV panels down that side and eventually connect everything up.
You know, there's some things we have to do still, but it's just nice that it's on the ground now, so I feel good. We've got a lot of sheathing that we have to do on the exterior. Interior work probably won't start for another couple weeks because we just want to make sure the house is ready to go on the outside.
Today we're working with the barn boards that we brought down from upstate in Illinois, up from Rockford, from Cam's grandparents' farm. As you can see, there's some lovely texture in here, some real sort of history. So it's kind of an exciting part of the project actually, because you really get to see the building come together. We're also incorporating a lighting feature in this wall system. So we've got LEDs that are going to be behind each barn board, and we're hoping that this light will spill out behind.
We're the electrical engineering students, and we just kind of found this box of Ethernet controllable lighting. LEDs use a lot less energy than incandescent bulbs. So obviously we're trying to save energy any way we can.
Almost everything has been looked at to see how we can save energy, from appliances to lighting, to even the television.
Figured it out already?
I'm guessing, yeah, then we plugged them in. So that plugs into the power. That power plugs into the Ethernet controller box, and that plugs into the Ethernet controller box.
We've also got to work on how we can have these windows framed in nicely.
with these barn boards. You'll see how these lines here will relate very well to the window itself. It's taken a little while to resolve this detail, but we're really happy with the way that it's turning out.
The home uses reclaimed material from another Midwestern icon for the decking. The 2x6 boards were salvaged from a grain silo near Champaign.
In a similar way that you came out and saw us at the barn, locally down here there was a grain elevator that was being demolished, and that's what's forming the decking for our building. At least they get another lease of life for another 10-15 years at least.
This saves us producing a new set of trees, and the new set of trees is going to grow faster, and the cells are going to be much larger and much less strong. So if you look at the end of these, the grain, there's probably 25 years of growth here.
When you're thinking long term is, this wood grew and then it was used once and it's just going to be disposed of and actually fill a landfill. We got some rough wood here, which we're going to have to sand down and get ready.
Is amazing wood. It's very strong and durable, and right now we bring it here into our workshop and we're sanding it, and then we'll seal it, and we're going to let it dry out, and then it'll be incorporated into the rest of the solar house as part of the structure.
Things are kind of falling into their own kind of natural rhythm. The guys from Puerto Rico and Ecuador, they're working together really as a team, and they're really taken on board the decking side of things. Decking really ties everything together and makes it a lot easier to work on the other side. We don't need to be up and down on ladders. Those guys are doing a great job on the other side, on the south side. So yeah, that's looking good.
The first step is kind of the hardest, the slowest one, and once you get the trick of it, you start doing it faster and faster each time, and basically follow the same steps, and again you get used to it and it's just faster.
What you see up above me here in the peak of the roof is our foam-in-place insulation. It is typical throughout the house, and what it does is it provides us a very high R value for insulation purposes that gives us an R value between 60 and 70 and make it easier to control the temperature throughout the day.
I was just running a wire from the data acquisition system right to the roof cap, so I'm going to be able to put a temperature humidity sensor right outside.
The more feedback we get into the system, such as the more sensors and temperature we have throughout the house, the more efficient our system can run. So on a cold day, we're going to exhaust cold air outside, but on a warm day, we're going to use the heat pump hot water heater for cooling during the summer.
Behind me is a Minneapolis blower door, and it's for a blower door test that we're performing today to find air infiltration through our building. The blower door behind us has a fan component, and that component will blow air out. So we're depressurizing the inside, and therefore we can feel around different building elements to feel air rushing into it. You were probably at least 4 to 5 times better than some of the even normal houses.
Finally, the solar panels have arrived. Charlie and his team are putting them up. I've had a couple of days on it already, just sort of getting the process down.
These solar panels are some of the most efficient in the industry. They're sun powers. They're 225 watts a piece. These are pretty much the most efficient that are out there right now, though. We're going to have a huge system. We're going to have 40 of these guys. It's going to be 10 kilowatts.
What we're aiming to do is actually put power back into the grid. That's one of the competitions, one of the events in the competition.
They've got a really nice black finish on them. It's one of the nicer things about these panels is actually kind of the aesthetics of them.
They blend in very nicely. We also kind of think that they're very appropriate to this kind of application where you have a standing seam roof, which is very vernacular, and then there's the system to connect them to that system very simply. It's almost like something that you can do yourself, which is what we're aiming for in the market viability of this product.
Charlie called me this morning. I was at the library and he's like, yeah, we have a problem. And I was like, what's that? He's like, how soon can you be here? And I was like, about 10 minutes. And he didn't even want to tell me what it was.
What happened? Maybe a couple poor assumptions when we started putting the panels up. Thought we had a little bit more leeway with the roof space than we actually do.
We were off by about 5 inches, so we figured out that when we put all the panels on, we were going to be hanging off the west side of the roof about 5 inches.
The first thing that went through my head was oops.
Things never run as smoothly as you imagine in your head, especially when you set up tight modules of how you want to have something set out. Then the question is, if that is off a little bit, then everything's off a little bit. With the PV panels, it's got to be spot on. So we'll see how quickly they get them out the second time.
After a summer of hard work, the team celebrates the completion of their Gable home on the Illinois campus.
Put a lot of crazy hours into this, and I think that the house really speaks for itself. When you check it out, it looks great.
I like the building very much because it resembles the simple farm architecture which we see here around campus.
There's no words to describe it. It's like amazing after all the summer working on it, and the whole process is like seeing it together. It's wow.
Today we're finally setting off the first step going to DC. Basically packed up everything. We've got a 48-foot truck that's going to arrive in a couple of days to make all the decking. Right now they're taking off the roof cap.
The house is disassembled and carefully placed on a flatbed for its 12-hour journey to the National Mall. As the teams arrive in DC, they get their first look at the competition.
You don't look at the time. If you do, it becomes depressing.
Yeah, 12:20. It's not tomorrow yet.
The last piece of trespa is now going up. I'm just debugging the program on for the solar thermal array.
Team Illinois worked for 3 months building their house on campus. Now they must rebuild it here in just 7 days.
Last night was work. That's what it was.
We actually come down to crunch time in 10 minutes. We have the inspector coming to check out all our exhibits. Get these in place, but this is the last one.
The Solar Decathlon is a competition for schools of architecture and engineering to design from the ground up solar-powered, high-efficiency, self-sustaining houses. It's a 2-year project where these students work on their campus. They have to design the house, spec out the materials, purchase those materials, build the house. Then they take them apart, bring them here to the Washington Mall, where we set them up, make a village. And with 20 schools involved, then we run a contest to see not only which house looks the best and is most well engineered, but also performs the best.
Just got the foundations all set up. We're gonna wait for Homeway to bring the house over.
It's the first entry ever for the Ohio State University in the Solar Decathlon competition.
We are! Penn State! We are!
So we're really having a lot of fun. There is a lot of Big Ten rivalry here.
Well, we want to win. We definitely want to win, or at least prove ourselves that what we have is a viable product in terms of the house itself.
The other teams, they fill their site with decks, with plants, with all sorts of things to try and compensate for the fact that their houses don't really set on the land very well. You take a look at our site, it's all open, it's grass. I think that kind of plays testament to where we're from.
it all on. The last 3 decathlons I've been involved with as the electrical inspector, and I think I'm highly impressed not only with the industry and what it's going to do for everybody in the future, but the way these kids are doing it and designing it and utilizing it.
We actually just failed our electrical inspection, and we're waiting on a little bit of work to go through and give it a second shot.
Have one minor problem here that they can rectify. This has to be done by 8 o'clock tonight. If they don't complete by 8 o'clock tonight, they're penalized for 1 day of competition. Serious deduction.
We'll give them
Some of us have put in 36-hour days, and you just crash at the end, but you get up the next day and you do it again.
It's been a little surreal, I guess, after, initially when I was working on the project, I didn't even know that I was going to come to DC.
Does anyone want pizza? Is that okay?
Let's be inventive. Let's look at the technologies that are being developed and how do you actually get them to work and integrate together. These are things that raise the consciousness and get younger people into the game, that they say this is necessary. So the lesson these people are learning, future engineers and future architects will actually make this a reality in the future.
It's great on the mall to see the University of Illinois in competition, and as far as I'm concerned, it's Go Illini.
I'm Joe.
Hi, Joe.
Hi. Inside the home, we tried to take a home that would feel comfortable for a couple as well as for someone who's entertaining, and take the idea of not only energy efficiency but sustainability. The kitchen was designed with the use of a minimum amount of materials. It's all LED lighting. We wanted it to be a feeling of openness, so we don't have visual barriers such as turns or hallways or real heavy doors.
We do have a dishwasher.
The whole bathroom turns into a shower, so the whole floor is a drain. There's the toilet paper hidden
I was
under
going to
here.
say, where's the toilet paper?
It's, if you want to come around, it's under here, so it's safe from the shower spray.
The homes are open to the public while they are judged in all 10 categories. The winning house must not only have great technology, but it must be a great place to live.
We went for just drywall returns.
After a week of judging, the winners are announced. Team Germany takes the top prize. Illinois wins second place and finishes higher than any other U.S. team.
The students have been fantastic. It's the most amazing commitment I've ever seen. Both the setup crew and the competition crew here, just fantastic. It was great.
The preceding program was produced by the University of Illinois in association with the Big Ten Network.